Welcome back to the new playlist of Data Engineering Mastery. This is a new playlist where the oldest one was about mathematics of thinking, where we discussed about algorithms and maths. Within this new playlist, we'll be talking about real production pipelines, real problems, real fixes, real failures. And by the way, I am launching a Python formation. If you wanna subscribe, you can fill in the form within the description. And without further ado, let's get started. Today's episode, I get asked about most by data engineers, like joining major teams. How do you actually design a Medallion architecture that holds up over time at scale with multiple teams right into it? So here the concept is simple: bronze, silver, gold. Everyone draws the diagram, almost nobody builds it correctly the first time, and the mistakes are always the same three. Let me show you what those mistakes are, then the rules, the code, and the Databricks pattern that prevents each one. So okay, we have the three failure patterns I have seen in real architectures. First of all, we have the bronze, which is not really bronze. The raw layer is being duplicated and cleaned at landing time. It looks cleaner, it feels better, but you just destroyed your ability to replay from the true raw source when you have a bug in the deduplication logic, and you have no ground truth to replay from. The whole point of bronze is to preserve exactly what arrived. The moment you modify it, it stops being bronze. The second, which is silver, has no merge strategy. Late arriving events from 3 days ago that just arrived are being appended to today's partition. So the same order now exists in two places: the original record from 3 days ago and the late arrival today. So every downstream gold table is double counting revenue is wrong. Nobody knows it goes undetected for weeks. And third, gold is just a copy of silver. Select star from silver where dates equals today. Written to gold, gold adds nothing, no aggregation, no business logic, no server optimization. It's pure duplication that costs storage, compute, and time. Tableau still scans silver level granularity. Dashboards are slow. Users complain. In this episode, the contracts each layer must honor and the code that enforced it. Okay, so what each layer actually does is, so before any code, let me give you the contracts for each layer. These are not guidelines, they are rules for each layer. So for the bronze, the contract is exact copy of the source, never modified, never deleted, append only, store exactly what the API or Kafka or file system sends, add audit columns, ingestion timestamp, source name, row hash, partition by ingestion dates, not business dates, no deduplication, no validation, no business logic. Format is Parquet or Delta in append only mode. If you break this contract, you lose the replay. Okay, then for the silver, the contract is deduplicated, validated, and conformed data. One row per entity, merge on the business key. 8 points handles the late arrivals, Pandera or Great Expectation Schema validation on every batch. Normalize types, timestamp to ETC, currencies to USD or whatever currency you're working with. Partition by business dates, not ingestion dates. This is the key difference from the bronze format. And Delta Lake merge requires it. Okay. For the gold, the contract is aggregated business metrics, ready to serve BI tools, pre-aggregated. Group by is done here, not in Tableau. Z order on high cardinality filter columns, optimize regularly to compact small files, one table per business metric or KPI domain. BI tools get read-only access. Read-only access, which and write only via the pipeline. Format delta lake with optimize and Z order. So look at the three cars in this slide. Notice how each layer has a strict format badge. At the bottom, bronze can use Parquet because it's append only. Silver and gold need delta tables because they need the merge and the Z order. So by going to the Databricks free edition platform, we'll be creating our catalog. Let's name it the Medallion demo, as in here. So in this catalog, we'll be holding all our schemas and data sets, basically delta tables. So we'll click here next. So we'll just stick to the default parameters. So here, as you see, it comes by default with default and information schema. We'll be going and creating our workspace. I already called it Medallion demo. So within here, I have created the notebooks that we'll be using just by clicking create a new notebook. So to not waste time, I will just go through the notebooks that I have created. So this first one is for generating our dummy data that we'll be working with. I mean, in your case, we'll be like having like real data. So in this case, I just run the cell and here is the dummy data that we got in the tabular formats with the columns we have and the types of the columns and step and stuff. Especially, I mean, we have the aggregations as well, and it gives also the C performance. You can see like the visualization of it. Now we'll go to the bronze ingest file. Here for the bronze has one job, which is land exactly what arrived, no deducts, so no validation, no business logic. The moment you start cleaning data here, you lose your ability to reply from the true raw source. So look at this, like here, Spark, so we create the schema if it doesn't exist and stuff. And here we are storing the full original row as a JSON string. If upstream changes the schema tomorrow, I can still redrive the silver from this. So that's your insurance policy. And we have the mode here of append. So this is the most important line in this file. Never change it to overwrite. That's the entire bronze contract in one word. And we have also this widget execution date for dates to have traceability. So now we'll go to the silver notebook. So here is where the real engineering happens. I'm reading today's bronze partition, then removing the duplicates, not by comparing every column, but using the SHA hash. So we're computing in bronze with complexity 1, comparison per row. So regardless of how many columns the source has, then the Pandera validates the schema before any write touches the silver. If upstream silently change the type, this fails loudly here. So not silently 3 weeks later when gold revenue is wrong. So the merge is the critical part. So in matching on order ID and only updating if the incoming event is newer. This is how you handle late arriving correctly. An event from January 1st that arrives on January 4th lands in the right partition without corrupting anything. So as you can see here in the results, then we have the gold aggregation. So gold is not a copy of the silver. It's like IC teams do, for example, select from silver where date equals today and call it the gold. That's a pointless duplication. So gold's job is to pre-aggregate so that Power BI never has to group by is done here. So optimize compact the small files that streaming creates, Z-order co-locate row with the same segments in the same physical files. Power BI queries skip 18 to 95% of the data. And yeah, so here is the logic behind it, and here I have put like some aggregations to plot and to look at them, and finally the results are plotted in here and these tables that we will be storing later within the catalog that we have created. So to check in, so we're going to go to the catalog and we'll be like viewing the data that's saved within every stage. So every stage we created a schema for it, and when we refresh we'll get the schemas, but eventually I will have nothing because I didn't run the notebooks. So that's what we'll be doing. And before we have this notebook, it's for running all the notebooks, we can use the dputils functionality where we'll be running each notebook using code, using the dputils.notebook.run with the name of the notebook. So instead of running them manually, so this is what I'm going to do. I'm going to run each cell alone in order to plot and have the delta tables within the catalog we created. And now we'll be refreshing, and here we are with the bronze layer. We have the orders row table, and we'll be doing the same for the other notebooks, which is the bronze ingest with also the silver transform. It may take time because the build of the Spark job takes time. So this is not a good idea to have like the Spark job for small jobs because the build takes time, but the execution is super fast because it's using the distributed system. Here you can use the functionality of Genie code, which is an LLM that helps debugging and stuff. It's like an agent provided by Databricks, which is really, I tried it and it's really powerful. And yeah, now I'm going to run this cell for the silver transform notebook, and it takes time. Cool, so it's executed, and here we have the results now. Super. Now to the gold aggregation notebook. We'll be waiting. So now we performing a map and reducing operations. So as we're using the group by operation, and we'll be creating the schema if it doesn't exist for the first time, which is the gold layer schema. And yeah, it's executed. It's super fast actually. And now for this notebook, it's going to do the same thing as I did manually. So it's plotting here, running notebook one, then it's waiting. The status is pending until it's executed and stuff. So I may not be waiting for it all to be executed because I executed them manually. And now let's have a look on the catalog to look at what we have created. So here, as you see, it gives succeeded. The first notebook has run. Now there's no need to wait for the others. Here, this query, I used it for cleaning all. So by dropping the catalog when I finish, because it consumes resources. So now I go to the medallion demo. I have the bronze layer, so I have to refresh first. We have the bronze layer, the two notebooks that created within notebook 2 and 3, first and second. We have the silver layer that creates the table within the notebook number 2. And here we have the notebook number 3, the last one regarding the gold aggregation. And now I'm going to drop everything to clean the resources, and it's going to give okay, but it's gonna take some time, so I'm going to let it until it finishes. So yeah, that's it. Let me show you how to write all the three layers together into a single observable or retrievable Databricks job. So look at the workflow diagram at the top. We have 7 tasks in sequence: set parameters, ingest bronze, validate bronze, transform silver, build gold, optimize gold, then alert on failure. So each task is connected to the next with a dependency. Silver only runs on after the bronze succeeded, gold only runs after silver succeeds, and optimize only runs after gold finishes. The alert task is on the failure path. It runs automatically if any tasks fails. And The YAML on the left is a Databricks asset bundle definition. This is the modern way to manage Databricks jobs. Version control in Git. It's deployed with a single CLI command with Databricks bundle deploy. The 5 workflow features worth highlighting from the right panel. The task dependencies, the enforced execution order. If bronze fails, silver never runs. Silver cannot corrupt its output from a failed bronze. The retry policy, max retry is 3 on each task. A transition network error does not require manual intervention. Execution dates parameter passed to every task to backfill January 5th through January 10th. You run the job 6 times with different execution dates values, no code changes, same pipeline. Failure alerting, the last task in the pipeline is a webhook call. Your team gets a Teams or pager duty notification with the pipeline name, execution dates, and a direct link to the failed run in Databricks. The Databricks asset bundles your job, your definition lives in the version control, changes go through the PR review, every deployment is reproducible. So that break naive Medallion Architecture, the schema drifts, upstream changes without warning, and upstream team adds a new column to their API response or rename one or changes the type. How should your pipeline handle it? So the schema drifts in bronze always allow schema evolution. Merge schema equals true. On the right means Delta Lake adds the new column to the bronze table automatically. All rows get null for the new column. New rows have the value. Bronze never breaks on the new columns. For the silver, validate the known columns strictly. Strict equals false. In Pandora means extra columns are allowed through, but if order ID or amount changes type, it fails loudly. Also detect new columns programmatically. Compare the incoming columns against the known schema. If new columns appear, send a Slack alert. For example, if you're working with Slack, a human should decide whether to update the silver schema or reject the new column. Never silently accept unknown schema changes. Late arrivals, an order from January 1st arrives on January 4th without merge. You would append it to January 4th partition. Now the same order exists in 2 partitions, double counting. With merge, the match condition is in order ID, not on dates. So the late arrival matches the existing row in the January 1st partition when matched updates with the events TS condition updates if it's newer. No duplication, correct final state. But gold has already been computed for January 1st. You need to reprocess it. Use replace where instead of write the report date equals, for example, to 2024-11 partition. This rebuilds the January 1st gold from the correct silver. Only that partition is touched. Everything else is untouched. And when the architecture starts to struggle at scale, 6 problems and 6 fixes. The problem 1, silver queries are getting slower each week. The fix is to run vacuum. Delta retains 13 days of transaction history by default, so all deleted files accumulate and slow down file listing. So set vacuum retains to 7 days and run it weekly. Also run optimize on the silver weekly. Problem 2, gold BI queries timeout for date range filters. So the fix is that you are missing Z order. Run optimize plus Z order on the columns your BI tools filter by. Usually report dates and customer segments. So file skipping will reduce the scan by 18 to 95%. Then the problem 3, multiple teams are writing to the same silver table. The fix is the Delta Lake table access control. One service principal per upstream team. Write access is exclusive. Only the owning pipeline writes to silver. Other teams get read-only access. Concurrent writers without access control cause data corruption. The problem for bronze partitions are getting too large, so 10 gigabytes plus files. The fix is to add a sub-partition partitions bronze by both the ingestion date and the source, or repartition before the right to control file size. Target is 128 megabytes to 1 gigabyte per file instead of 10 gigabytes. The problem 5, streaming ingestion creates 100,000 small files. The fix is to enable the delta auto-optimize with two tables properties. Delta auto-optimize auto-compact equals true. Compact small files automatically alert writes. Delta auto-optimize optimize write equals true. It reduces the number of files written per batch. Then the last problem, the sixth problem, late arrivals are triggering 13 days gold reprocessing. The fix is to accept a watermark, only reprocess gold partitions within the last n days, 7 days, 14 days, wherever the business agrees to. Older corrections go through a separate reconciliation table. You cannot afford to reprocess 13 days of gold for every late arrival, which is really massive. Okay. 4 rules to take away from all of this. 1. Bronze is append only, never overwrite it, never modify it, add row payload ingestion TS and row hash audit columns, partition by ingestion dates. This is your replay guarantee protected. 2. Silver uses merge with a business key, not append when matched. Updates only if the incoming event is newer. This is what handles late arrivals and out of order events. Correctly partitioned by business dates, not ingestion dates. 3. Gold is pre-aggregated. Group by is done in gold, not in Tableau, not in Power BI. Run optimize plus the Z order. After every write, use replace where for idempotent partition overrides. BI tools query gold directly, so they never scan the silver. 4. Orchestrate with Databricks workflows, task dependencies, enforce execution order. Max retries on each task, handles transition failure. Design makes retry safe. Execution date parameter enables the backfill for any date range. Version control the job definition with Databricks asset bundles. So drop a like if this was useful and tell me in the comments which is of the 3 failure patterns at the beginning of the episode did your team hit. The bronze overwrite one is the most common. Next episode we'll be talking about Python patterns every data engineer uses daily, context managers, generators, retry decorators, data class pipelines, the patterns that make production Python code readable, testable, and reusable. So see you in episode 6.